I'd like to introduce Alex Vidrian, Technical Product Owner for OpenAir at Vitagroup, the healthcare specialist company behind EHRbase, the open source electronic health records standard. Alex is going to talk us through how they leveraged distributed SQL to build an electronic health record system for 8 million people running on OpenShift. So welcome, Alex, and take us away.
All right. Thank you, Chris, very much. Hello, everyone. My name is Alex. And I'm working with Vitagroup. And now I would like to walk you through how we managed to scale Vitagroup's heap and provide transforming healthcare for 8 million people in Catalonia. All right, so let's start off with some background. When it comes to health data, well, health data comes in various sizes and forms, and it's usually stored in these big data store silos that are usually difficult or even impossible to access or exchange outside of the main solution provider's walled garden. With Vitagroup's open health data platform called HEAP, we are set to change this and make data available to those who would really benefit the most from it, it's like the patients, healthcare providers, and researchers worldwide. And you can see here a map and the list of all the countries that already benefit from our enterprise and open source solutions. Now zooming in on one particular country, Spain, and the work that started there in the Catalonia region. Spain's health sector is undergoing some significant transformation, not only within Catalonia, but across all autonomous communities and regions. And this effort reflects a broader trend towards digital consolidation in healthcare. And Catalonia is at the forefront of this innovation. The business goal behind the Catalan Digital Health Initiative, as this project it's called, is to unify the health data across the region and then the whole country so that inhabitants and tourists can get medical care regardless of the location. And to put this into perspective and give some numbers on the project, the health region of Catalonia has more than 7.5 million inhabitants and 500,000 tourists, totaling at around 8 million people population. And for this population, around 57,000 healthcare professionals are working in over 1,000 health facilities to serve them. And technically, the system will need to incorporate somewhere around 30 million EHRs at first, which we collect from different health information systems. And their data total combined would is expected to reach billions of data points, and the daily transaction load peaking at around 40 million transactions. Of course, at the core of this project sits Vitagroup's health intelligence platform, and together with Yugabyte, IBM, MedBlocks, and Kyndryl, we are working on creating this end-to-end clinical data platform that can handle such requirements. All right, so when it comes to a platform like this, we're not just talking about numbers. We also need to consider the standards, and because the Catalonia project was also thought to be open, and it's is using these open standards mainly for future-proofing the solution and not be tied in the end to some provider. This is where the HEAP plays another crucial role, because it was built to be natively interoperable with different systems and using some open standards like the one I'm about to talk about. First off, we have the storage of the health data. This storage is achieved through our backend EHRbase, which Chris already mentioned in the beginning. EHRbase is an open EHRbase backend, and it's also an open source solution, which is extended by enterprise features and SLAs, and it's making it suitable to be used in these mission critical environments. About OpenAIRE a bit, because I'm not sure how many of you are familiar with it. So OpenAIRE is an open standard specification for managing, storing, and accessing health data. And by using OpenAIRE, the main benefit is usually that the clinical data is stored in a standardized, semantically rich, and machine-readable way. And besides that, one of the powerful features of OpenAIRE, which we will also tie in a bit later, is its archetype query language, or AQL for short, which is a declarative query language for accessing this data stored in the OpenAIRE format. And it's not tied to a certain schema. So providers of solutions based on OpenAIRE can use underlying any schema they wish to, because there is this abstractization above it. Of course, besides OpenAIRE, we are also using other standards like the HL7v2 or FHIR for protocols for exchanging and mapping demographics health data, but we'll keep the focus for now on the storing of data, since this is an SQL-centric event. And to now complete the picture, here are some use cases that are also part of this health platform that we're building in Catalonia, and they are usually common use cases when you think of healthcare provisioning. And they range from a patient who requests vaccination or fills in a regular questionnaire, to the doctor viewing patients' lab results, or even prescribing medication. So usually, I got a bit excited. So the data for such cases, it usually comes from third-party applications like health information system that is already used in a clinic or a hospital, and that we are integrating with. Okay, so let's see then how it all ties to Yugabyte, and how we chose on running YugabyteDB as our underlying database. Well, again, going a bit in the past, so when the RFI, so the request for information for the Catalonia project was announced, our team started looking into options of making sure that EHRbase is as ready as possible for such a task. And for that, we needed a database who could fulfill some key factors. And I will go now a bit to the list of factors. So it was really important that it supports distributed ACID transactions for strong data consistency. It should offer strong resilience with an RTO of smaller than an hour, and a 0 RPO, and a very high availability. Then, of course, for us it was important that it's Postgres compatible, but also it's cloud native. As I said, it needed another bonus was it being open source, so that it doesn't it doesn't lock you down, and it provides some vendor independence and future proofing. Given of how OpenAIRE and these clinical documents are stored, it was important also for us that It has good support for JSON documents, and of course, it should offer enterprise class security with data encryption at rest and as well as in motion. So right from the start, YugabyteDB was a great candidate by checking all the boxes. Of course, we did not just look at Yugabyte. We also looked at how we can scale Postgres. We've also looked at some NoSQL databases like MongoDB. However, with Postgres limited horizontal scalability and the transaction limitations that Mongo had at the time, we decided that Yugabyte is our way to go. And besides all this, a particular strength of Yugabyte was that it also supports multi-document transactions across multiple shards. Also doing this in high performance and low latency, which was really important for us because the OpenAir semantics has these contributions which concurrently handle operations on multiple documents and objects within a single transaction. So we were pretty much decided on Yugabyte. So the next step was, then we need to make sure that we can meet the performance requirements. So we set off and we've completely redesigned our data structure, and we've completely refactored our archetype query language translator, or how we call it, the AQL to SQL engine. This was a bottom-up process where we started by, we looked at the DDL and the SQL queries that we were producing so that we can prioritize which features we want to support first. And this also allowed us to be faster when it comes to designing, what will then happen in the end, what will reach the database, because we could always test this against Postgres and Yugabyte before we implemented the logic. So we were doing tests against the database directly, and then we ported them into, this should be the translation logic that would produce this. It was an interesting journey, but we reached the point where we said, we are now the improvements are quite visible, and we also always run performance tests, and you can see on the graph there, we in the end managed to demonstrate the use of EHRbase with Yugabyte in a scenario of involving a population of 10 million patients or EHRs with 2 billion structured clinical documents, or in OpenAir terms, compositions with varying complexity. And with this, Vitagroup's heap was chosen to become the central component of the Catalan health system. So we continued extending our AQL to SQL engine, and in the Q2 of this year, EHRbase 2.0 was made public and open source with its brand new and improved AQL to SQL engine. So now that we've seen how we pretty much got here, let's see how things look like right now, and also the challenges that we had once the system went live. So as the architecture landscape in the current setup that we have on production in Catalonia, there is an X cluster, which is it's asynchronously replicating, And you can see there on the right side the schema of the production cluster, and on the left side you can see some specifications of what we are using, like the fact that we are running on OpenShift. We are using 2 data centers, active and passive. We have 3 nodes with 30 cores per universe, which totals in 192. As I said, we have asynchronous data replication, which is non-zero RPO. And at the moment of creating this presentation, we had 30 million EHRs loaded with around 1 billion composition. Maybe some highlights to make here. So in regards to the non-zero RPO, this was basically a decision that we had to make in order to improve performance. So however, during a switchover, the RPO is 0 because it always waits for the in-flight data to be committed. Usually with usual activity, when we don't have a massive load, so since this is a new system, we have to gather data from all the other existing systems. And but when we are not doing massive loads, we usually end up having around 22 to 25,000 requests per day. This is somewhere around 50 to 60 requests per second at max. But when there are also massive loads happening, we do reach our targeted peak transactions per day, like 40 million, with around 170 requests per second. So this is our how it looks like, the landscape at the moment. And let's talk a bit about the challenges that we had. And the first one of the first challenges we had, we are now live, we have a running system, so how do we deal with DDL changes? Once the EHRbase and Yugabyte reached the production stage, of course, we could not stop with evolving EHRbase and introducing new features. But due to the complex nature of OpenAir, and we had to sometimes also make data structure changes, so we could not just freeze our data structure and make sure that have everything that we need. So we had to think of a way of how do we then deal with these data structure changes when we are dealing with a system of this size, which only grows bigger day by day. And we already had all the EHRs loaded, and they came with some clinical data. As I mentioned, we also had massive data loads happening in parallel on the same database that we were supposed to be doing changes. And of course, we needed to make sure that we kept everything in a short and manageable downtime window. So our answer to these challenges, we first made sure that we have our sandbox environment as closely replicating the production system as possible. Of course, on a smaller scale, but using the same configuration, using the same data distribution. We've set up this sandbox. Of course, it was disposable, so we could always reset it and load it again with data through our data loader tool. So that was our playground where we were testing, not only doing performance tests, but also testing migration while the system was under different loads. So normally we rely on automated flyway migrations. However, in an X cluster setup, this is kind of cumbersome to achieve. So we needed to replicate the flyway migrations process through handcrafted and optimized scripts. And for that, we had these three type of scripts. So starting with pre-flight scripts, which we built them with a configurable batch and bucket size, so that whenever we were doing these migrations, we could configure and execute as many in parallel as the system would let us at that moment. Then second, we had migration scripts. The migration scripts were those which required actually some application downtime, so critical data changes can be made. So we had to keep these scripts and reduce them to a bare minimum. So yeah, the downtime is as minimal as possible. And of course, at the end, we had to have these cleanup scripts that removed any leftover indexes or temporary tables that we still had, but also that were still in case there's some residue data that still needed migration, we could maybe do it also through these cleanup scripts. So yeah, in order to achieve this this process, we've closely collaborated with Yugabyte and IBM to make sure that we can execute these migrations, and that we also have a well-defined process when doing that. So now that we've dealt with that, one of our second challenge, and I'm guessing it's usually a challenge in any system and any big system, is of course how do you deal with the performance, and how do you do performance optimizations. So in our case, since OpenAir and EHRbase don't impose any, let's say, condition on what type of clinical data you can store, because that's usually defined through the clinical data templates that are uploaded in the system. And also because AQL is an abstraction over these templates and this schema, this OpenAir schema, but it also has to produce SQL. We did end up in having some performance issues regarding certain AQL queries, and even some of them were patient-related queries. So where you would usually expect that you don't have as many amounts of data as you would have for a population query, for example. So for that, we had to, in order to optimize, we had to go over multiple iterations and try out different solutions. One thing that we tried out was, we are trying to configure our query hint strategies so that we don't always have to do new deployments. So we've came up with a set of different strategies that can be changed at runtime, so we can test out which one performs best for which query. And just to name, we had, for example, like leading hints with leading statistics and nested loops and scan methods. Then we had the statistics strategy, which was using the statistic-based planner with nested loops. And these are just to name a few. Then, of course, but this one we kind of relied from the beginning when we started testing out stuff against Yugabyte were batch nested loops, which we enabled right from the start because it would help us a lot reducing the number of joins. And then we also, once it was introduced, we also were relying a lot on the cost-based optimizer. And yeah, this was in, I guess, on 2024.1 is what it was introduced as maybe a preview. But yeah, we've testing it since before, and we were really happy with the performance that it brings. So we managed by trying these different strategies for hints, and also trying these Yugabyte features, we managed to get some performance improvements. But most of the performance improvements that we managed to got were after a hands-on workshop with some Yugabyte experts, where we sat down together and we analyzed the query planner behavior, and we could try out directly on the spot different improvements to the data structure, to how we are generating the SQLs. And yeah, you can see in the table below so the performance improvements that we gain. So you have the first few columns represent the EHRs and the number of clinical data that is associated to EHRs, but where you see the blue bars, so the first 3 columns with blue bars, those was the performance before the workshop, and the last 3 was the performance that we managed to get after the workshop, which in some cases was by a factor of 10 or 12-fold. And for also, maybe because I'm talking about the AQL to SQL, you can see on the right side just a small example of how an AQL query looks like at the top, and then the generated SQL which comes out of it. And yeah, that's just the snippet of the SQL. It goes down a lot. So yeah, basically this is the experience that we had, and that the challenges that we had while we went live. So now I want to maybe leave you with some lessons learned and what we are planning to do next. So yeah, in terms of lessons learned, we saw that the combination we got from EHRbase and YugabyteDB has proven to be capable of handling large scales transactional platforms. We've also learned that traditional automated migration tools like Flyway or YugabyteDB do face some limitation when it comes to large asynchronous systems that require some minimal downtime. We also encountered some issues with JSONB that we had to work around when it comes to JSONB indexes, because that's a limitation that we had at the time with YugabyteDB. And we started early with batch nested loops and cost-based optimized planner. But once we've learned how to properly use them, we saw that they could really bring some really good performance. And some next steps that we have, of course, we are focusing on expanding our AQL and OpenAir capabilities in EHRbase and in HEAP. And we are planning to improve our population level query performance. And we are working sometime in the future to also support these custom or secondary indexes, which could help a lot when optimizing for very specific use cases. All right, and with that, if you want some more information, please check out our Vitagroup HEAP page for an overview of our data management capabilities, or feel free to reach out to our team for any specific questions or maybe collaboration opportunities.
Thanks, Alex. That was excellent. It was an amazing run through of the project. Really, really interesting. And it's great to see Yugabyte in use as such an important use case, especially the fact it's the whole system is positively impacting the health outcomes for 8 million people based in Catalonia. It's incredible. Really, really good. So if there are any questions for Alex, please place them in the chat and we'll get back to you either in chat or in person. Thank you.
All right. Thanks for having me.